So we were discussing the manufacturing processes,
Yes, sir.
processing operations, what are the different processing operations, shaping process, what is solidification, what is particulate, then deformation process, then material removal process. Yesterday we saw some numericals also, they are done. Some students solved it also immediately. So generally the waste is more in shaping process and that is what you have to avoid. You have to minimize the waste. This is the family tree for the. And I also told you that this tool nomenclature is very important from examination point of view. And in certain cases, you cannot avoid machining. Like suppose if you want to have a very precise hole, like say diameter 25 H7, so 25 plus 0.02. So you have to go for grinding or you have to go for honing. So the most important machining operations are turning, then drilling and milling. And there are other machining operations like shaping and planing, then broaching and sawing. Sawing मतलब जो हम लोग हैक्सॉ से जो कट करते हैं, that is what is called as the sawing. Drilling, milling, you are familiar now. This operation is called as the plane milling. This is plane milling and this is called the face milling. Okay, so these are the different tool motions and tool mechanisms. That is what we saw, and we also saw how to find out the machining time. And there is a mathematical model also for material removal rate. That is how to calculate the material removal rate. So this I wanted to tell you. So this formula is based on the velocity, like how to find out the machining time. You must know what is the total length and divided by the feed rate. Now you have to take care of the units. Let us say now if this length is in millimeter, then feed rate also should be in millimeter per minute. So millimeter divided by millimeter per minute, so you will get the time in minute. If the feed rate is in millimeter per second, so you will get the time in second. But generally the feed rates are expressed in millimeter per minute, so that machining time you will get in minute only. In another formula from numerical point of view is V is equal to pi dn. V is equal to pi dn. So V is nothing but the cutting speed or cutting velocity, pi, and d is nothing but the diameter, and n is nothing but the revolutions, that is RPM, revolutions per minute. So the cutting speed is given in meters per minute and diameter also has to be in meter. So meters per minute and this is in meters. So right hand side you will get per minute and here also you have per minute. So the dimensionally it is same. Generally the diameters are given in millimeter. So you have to divide by 1000 to get it into meters. So the formula becomes V is equal to pi dn upon 1000. Pi dn upon 1000. That is the formula. Why 1000? Because you have to convert millimeter into meter. Then material removal rate can be found out by this relation. MRR is equal to V into F into D. So where V is the cutting velocity, F is the feed rate, and D is the diameter. So now if the feed rate is in millimeter per minute, you will get material removal rate in millimeter cube. If it is in seconds, you will get feed in material removal rate. MRR is material removal rate, so that you will get in millimeter cube per second. So this material removal rate is also very important because if you know the material removal rate, then only you can decide upon the horsepower calculations of the motor. Like suppose I want to remove this much of material, so what should be my motor HP? So the first calculation is material removal rate. Then second calculation is motor HP. What should be the HP? If I want more MRR, then I should have more HP. Less MRR means less HP. Now once I know the motor HP, then I can determine the machine structure, whether it is lathe machine or milling machine. Hmm. So the very first is that you have to have material removal rate, and then once you determine the material removal rate, then there is a formula for calculating motor HP. And then once you know the motor HP, then you can decide upon the structure of the machine too. Okay, so now we'll start with the casting process. So this I have to upload. So Nair, you can just remind me in case if I forget. I'll upload these two files, chipless and introduction to MT. And it's my appeal that you have to log in with your roll number, otherwise it is very difficult to mark the attendance. And preferably you write the roll number on the left hand side. Most of the students they have written, but there are few students like Mendonça. He is not writing his roll number. And there are few students who have written their roll number on the right hand side. So once again, I request that you please, first of all, you write down your roll number and you see that you write your roll number on the left hand side.
Yes, sir.
Yeah, please. So this was Dr. Abdul Kalam's vision. By 2020, India will be. We are starting with the casting. India will be a leader producer of quality castings. He had vision everywhere, not only in metal, in not only in nuclear science, but even in your metal industries also, and will be a large exporter of these items. Foundry matlab it is a place where this metal is melted and it is poured into the molds in order to form the shapes. That is what is called the foundry. In Bombay, there are foundries in Mahindra, bigger foundries I am talking. Mahindra Kandivali, they have very big foundries. Then Mukund Iron and Steel Company, that is at Thane and Kalwe. Earlier it was at Kurla. Now it is at Kalwe. So these two because they have very big foundries, but at the same time there are very small foundries also. Particularly if you visit Goregaon East and Vasai East, you will see many foundries, but those are very small, having small furnace. Then Tata had foundries, but at Borivali, but now that is no more. Tata still, it is everything is shifted to Palghar. So the foundry is nothing but it is a place where the metal is melted and it is poured into the sand molds. So have a look on this. This is called as the mold. Generally the mold is in two half like this. Mold is in two half. Now when it is in two half, it becomes prime responsibility that these two halves should match properly. Like suppose any product if you are making in two parts, then when you are assembling, it should match properly. There should not be any mismatch. So in order to avoid that mismatch, we have locating pins here. These. So these locating pins are also called the dowel pins, and there is a hole here. These locating pins, they locate these two halves. Manufacturing process में what we do, first we make these two blocks, plain rectangular blocks, then we drill and rim two holes for locating pins or for the oil pins, okay, and then with the reference of these two locating pins we cut this shape separately. Like I have drill and rim this hole, these two holes. Now with this reference I will do machining of this shape. Again with these two references I will do machining over this. So now whenever these two parts are assembled together, then this and this has to match each other, has to match each other. Okay, then there is something called the runner through which the molten metal is poured, then it gets solidified, and then again these two halves they are removed and the casting is taken out. So the casting is a verb, that is a process, product is a noun. Okay, so where are the applications? As I said earlier, it was limited a few years back, 20 years, 25 years back. It was limited only for the grey cast iron, but now almost everything you can cast. Okay, like you have aluminum wheel. Huh? This is this is a cast. Again, in casting there are different processes like sand casting, huh? Die casting, investment casting, centrifugal casting. So that we'll see. Now bronze. Bronze is nothing but copper plus tin. Bronze is nothing but copper and tin. Okay. So these are some bronze castings. ये सब बड़े बड़े statues है, हाँ? Those are all cast. They are all made up of bronze. The property of the bronze is it doesn't rust. It doesn't rust. Okay, the railway workshop, Jamlapur, West Bengal में, they have the biggest foundry. अच्छा, one more foundry you can see that अपना Central Railway at Matunga, they have a huge workshop. It's a very beautiful workshop. If you get a chance, try to do internship at least for a period of 1 month. It's like a darya. You will learn everything about the mechanical engineering. So here you will see all the processes like casting bolo, forging bolo, die casting bolo, machining. So there is no limit for learning. Okay, so that is at Matunga Central Railway workshops. Then there are other applications like in transport, that is vehicle, in industrial machineries like lathe, milling, uh, etc. etc. So the applications are very wide. Again, in automobile, the engines they are cast. Engines में मतलब not total full engine, but the parts of the engine like cylinder block. This is made up of cast iron. Then you have radiator part, hmm, then exhaust manifold. These are aluminum alloys. Then जो differential gearbox है उसका जो casing है, that is again cast. So vehicle manufacturers they have to have foundry because there are many parts which are cast. In railways and shipping also they have wide applications like railway engine frame, bogie ka frame, railway plates, ship ka anchor fitting, then this ship fittings, and then bollard. So these are the different products which are used in railways and shipping. Again in aerospace also, like engine fuel pump, it's fully cast, totally cast. Again, casting not necessarily it is sand casting. There are different processes like sand casting. I am telling you again, investment casting, centrifugal casting, precision castings, many types of castings. So there are some products which can be produced by sand mold, but there are some products which we have to go for centrifugal, or you have to go for investment, or you have to go for shell, or you have to go for wax castings, depending upon the product. Then this is the engine part, this is chassis part. Chassis part, now see here titanium aluminum alloy is cast. Ti aluminum alloy is called. Impeller is a part of the fan. then fuel pump, coupling part, then brake mounting. These are all testing applications. In machine tools मतलब lathe machine, milling machine, drilling machine. These are called as the machine tools. It is not to be confused with cutting tools. Machine tool का मतलब lathe, milling, planing, grinding. These are called the machine tools. Uh, so there again you will find many applications. Then compressor everybody must have seen. जो compressor का जो cylinders रहता है, तो उसके ऊपर का जो केस है, those are all cast. Handwheels, these are cast. Handwheels मतलब गाड़ी का handwheel नहीं, it is called as the steering wheel. This handwheels मतलब लेथ मशीन के ऊपर आपको handwheel दिखाई देंगे. So with this handwheel we move the apron or we move the cross slide, that is we give the longitudinal feed or we give the cross feed with the help of this hand wheel. Then spanners, shaft housing, coupling part, frame housings, all these are cast, not necessarily by sand molding. These are the recruitment, these are the requirement, not requirement. Uh, for automobile, it is very high. So at the top, you will see automobile, followed by railway and shipping, then aerospace and defense, then sanitary. Sanitary में ज़्यादा करके pipes आते हैं, हाँ, pipes, बाथरूम का fittings है, bathroom pots, those are all cast. Okay? बड़ा बड़ा drainage lines are all cast. Okay. Of course, now it is replaced by plastic PVC pipes, which are done by centrifugal casting. So that is also cast. It is done by centrifugal casting or by rotational molding. Then you have machine tools. Machine tools, as I have been saying again and again, it is nothing but lathe, milling. Then electrical and energy. In electricals also, like switchgear industries, circuit breaker industries, the switches, they are all cast or rather they are molded. Basically, they are thermoset plastics, so they are molded. Industrial machineries means all big machines like the machineries which are used in rubber mixing workshop, or the machineries which are used in textile machinery, or the machineries which are used in newspaper industries, जहाँ पे कि न्यूज़पेपर बनते हैं, पेपर बनते हैं, कागज बनते हैं. टेक्सटाइल इंडस्ट्री में we get a cloth, or even in case of power stations like Tata Power thermal station, so they also need machineries. So there also you have all cast equipments, constructions, farming, mining. So there also the machines are cast, construction ka machines. Most of the time they are cast. Then biomedical implants. Those are all investment costs. Biomedical जो implants है, for example, dental implants. Those are all investment costs, precision costs. So here they have shown how the evolution is taking place right from the steel forging to the new direct investment casting. So earlier it was forged, but now it is replaced by casting. Casting is more economical than forging. Advantage of casting is the material weight is as compared to other processes, the product weight, the material weight is less or low. Fabrication also can be replaced by casting, fabrication. Only what you have to remember is that you should have quantity. You should have quantity like say 1,000 pieces, 5,000 or 1 lakh pieces. Just for one piece, it is very difficult to go for the casting because you will have to make a mold. And for making a mold, first thing is that you have to make a pattern. Okay, which is pattern making and mold making is expensive, so you cannot afford it for one single component. Okay. So axle housing, now this is an assembly of six parts. Okay. So now fabrication means, basically fabrication means you have to understood that part which is made by welding. Hmm. So different parts are cut and they are welded. Like suppose for example this component. So here you have plate, then these are called the ribs, and this is called the bush. So you have these components which are made separately, they are cut separately, and then they are welded here. Okay. So there is a lot of labor involved. This is the photograph of me. If you decide upon the casting, then you have to just invest only in the mold, and there is no welding. It looks good. So these fabricated parts also can be cast, provided there is a quantity. That is what you have to remember. Huh? So what are the advantages of the casting? Hmm? First is cost and weight reduction. Metal parts getting thin. One means why the need of casting? Because we have to reduce the cost, we have to reduce the weight. The parts are becoming thinner and thinner. You know, isn't it? The space requirement is getting lesser and lesser. Earlier, you know, the computers, the first generation, second generation, first generation computer was like a double decker bus. Second generation computer was like a room size. Then third generation, that is your desktop. Then desktop के बाद you have laptop, the computers which can be operated by keeping it on lap. Then you have palm top. मतलब the size is reducing, and that's why the need of casting also has started, increasing. Plus, there is a technological growth in softwares like CAD, computer-aided design, then CAE, that is computer-aided engineering, and computer-aided manufacturing, that is CAM. Remember, CAM is for computer-aided manufacturing, and CAD is for computer-aided designing.
Yes, sir.
Yes. Yes.
So,
Hello. Yeah.
in casting, the molds are reused or are they one-time use?
No, there are depending upon the type of casting. Like suppose if we go for die casting, then the molds are reused because they are made up of metal. If you go for sand casting, then there only the life is only one, because the sand casting molds has to be broken in order to remove the product. Okay,
Okay,
so
sir.
they are reusable as well as the life is one piece, and the life can be 1 lakh pieces also. So depending upon the type of the casting. So if you talk about sand casting, then the tooling cost is less. There is less material wastage, and the manufacturing cost is also less. So whenever we'll discuss now various type of sand casting, so that time you will understand this. Then,
Yes, sir.
then the casting has footprints across the globe. So in Russia, 4.2 million tons of castings are produced. Japan में 4.4. China is the biggest consumer of the casting, 35.3 million tons. And India is the second one, second number, but still miles away from the China. It's 7.4. It's almost 20% of the China. See, the first is China, then India, then followed by USA, Russia. This is not important from examination point of view. Okay, so this is production which is given in million tons MT, and these are the number of foundries. Like China in 2010, they had 26,000 foundries, as against 4,600 foundries in India. So this is a graph, how the growth is taking place per year. So China, it is the graph is upward, so it is rising up and up. Foundry productivity. See, productivity is nothing but output upon input. So productivity का मतलब है more and more of output with less and less of input. Your input should be less and your output should be more, or rather your input should be zero and output should be more. That means, ideally speaking, without doing any investment, I should get my output. But that is not true, isn't it? But it can be modified that with less inputs I should get more output. That is what is called as the productivity. So ऐसा नहीं है कि I have made 600 vehicles, in two shifts. That figure is not important. I have made 600 vehicles with so much of input, with this much of input. That is what is required. Okay, so that is what is for the productivity. Like suppose there are two production managers. So one production manager, he has said that he has made 300 vehicles in one shift. Another production manager, he will say, sir, I have made 500 vehicles in two shifts. So who is great? Obviously the manager who has made 300 vehicles in one shift, he is great, because the person manager who has made 500 vehicles, he has used double resources. 16 hours में 500 pieces. He has made another number A, production manager A. He has made 300 vehicles in 800 in 8 hours. 300 vehicles in 8 hours and 500 vehicles in 16 hours. So who is great? Of course, the first one, because time he has taken more, resources, labor, worker he has taken more, energy he has consumed more, so he has used more inputs. The figure looks big, 500 as compared to 300, but productivity wise, it is not good. So the productivity wise, Germany is the best. And see, India, China is the worst, and India is third last. So that means what? We are taking more inputs to produce the output. Okay, whereas Germany, they are taking less input to produce more output. This is what some foundry clusters in most of the there are good foundry clusters in Ahmedabad, in Gujarat, that is near Rajkot. Rajkot also they have very good setup for the foundries. In Maharashtra, you can see foundries near Kolhapur. Then Belgaum, Coimbatore, Aurang, Jalandhar, Ludhiana. So we have, we are among the top 10 producers of the major minerals and metals. So we can get the metals required for foundry. Then we have sufficient manpower. In the manpower wise, there is no issue. We are next to the China. So we have large and young pool of technicians and engineers, and we have very good market also, isn't it? The peoples, why the peoples, foreigners, they invest here, because they know that India uh, has a good market and they can sell their products more in Indian markets. So that was about your casting. Still, it is not over because it is very it's quite exhaustive from examination point of view as well as from syllabus point of view. So as I said, castings, they are produced in foundries. Okay. Let's say now suppose if I want to make this, pattern. See, for any casting you need to have a pattern first. You have to first make a pattern. So pattern making is again another subject. And with the help of the pattern, you can produce this cavity. Okay. Now you have to remember the pattern will look exactly same as the product. Like say this is my pattern, so the product will look exactly same. I use the word it looks same. Dimensionally there will be difference. There will be something for the shrinkage allowance, draft allowance, etc., etc. But the shape wise, your pattern will exactly look like your product. That is what you have to remember. Hmm. Then patterns are made out of wood, aluminium, polystyrene. Hmm. Polystyrene is a plastic, like your pens. आपके जो लेक्सी के planes है, pens, huh? They are all made up of polystyrene. Hmm. You can, I don't know how many of you are familiar with the plastics. There are different type of plastic like polystyrene. आपका जो पेन्स है, polyethylene bags, लो डेंसिटी पॉलीइथिलीन, हाई डेंसिटी पॉलीइथिलीन, आपका जो गार्बेज बैग रहता है या आपका जो पतला वाला गार्बेज बैग रहता है, दे आर मेड अप ऑफ लो डेंसिटी पॉलीइथिलीन, पॉली पीई। आपका जो मिल्क का बैग रहता है, तो ऑल थिक्स, दे आर हाई डेंसिटी पॉलीइथिलीन बैग्स। एबीएस, then PVC, that is drainage pipes, polystyrene, which is used for your ball pens, then acrylic or polycarbonate. Acrylic, you are familiar, आपके जो lens है, हाँ spectacles के, they are made up of acrylic or polycarbonate because they have 100% clarity. The glass का जो sheets है, the sheets which are kept on the tables, they are either made up of glass, that is कांच, or made up of acrylic. Hmm. Earlier we used to use glass sheets on the table, but now we use acrylic sheets. Why? Because glass, from safety point of view, are not advisable, because if it falls down, it breaks. Huh? Then the sharp corners of the glass can cause the accident also. So that's why acrylic sheets are used most commonly as compared to the glass. So what I was telling you, that pattern will look exactly same as your product. Okay, so now this is how to make a mold. Okay, so for making a mold, you remember you should have a pattern first. Okay, now I am taking a box like this in which I am keeping this pattern, and surrounding this pattern, okay, there is now sand is poured. This sand is poured surrounding the pattern. Okay, now what will happen? I am not able to remove this pattern. I cannot remove this pattern because there is a sand surrounding. Okay, and there is a negative taper. ये जो taper है ना, ये negative है. Had it been ulta like this, which is for the positive taper, then you could have pulled the pattern up. Okay, but now in this case you cannot, because ये sand में फंस गया है ये pattern. Okay, there is the sand surrounding here यहाँ पे, so it is impossible to remove these patterns. So since this is made out of polystyrene, which is plastic, and you know plastic melting point is around 150 to 200 degrees Celsius. So the moment you, what we do, we just pour the sand, and then we pour the molten metal. Okay, now molten metal will definitely have a temperature of 1300 degrees Celsius. Molten metal. So in this 1300 degrees Celsius, this polystyrene, which has a melting point of around 150 to 200 degrees Celsius, can melt very easily. Okay. So what will be the life of this polystyrene pattern? It will be only one piece. Only one piece can be cast. Okay. So the polystyrene will burn when you are, putting, or when you are pouring the molten metal, and the gas will escape out. There is something called as a vent holes, venting. So venting is nothing but the small holes, a very small hole of 20 micron or of 50 microns. So the small holes are drilled inside this sand mold, point one ka, so through which the gas will come out. Okay, but you have to also see that the hole should not be large enough. These are called the venting holes or venting lines. The depth of the venting line should not be deep, otherwise what will happen, if the hole is big or if the depth is more, then what will happen, the molten metal will come out, and this is what is called as the flash. Hmm. So before casting, now you know what is casting. Before casting, we have to make a pattern. So pattern is nothing but a replica of the object, as I told you. Just a minute. So pattern is nothing but the replica of the object. That is, जैसा आपको object रहेगा, same pattern रहेगा, shape. Only the size will differ. Okay. This is a sand mold. हाँ, और sand mold का जो नीचे का portion है, which is lying on the floor or which is in contact with the floor is called as the drag. And जो ऊपर का portion है, that is what is called as the core. So the bottommost portion is drag and the top portion is called as the core. How you will remember? Normally along the floor you drag something. ना so आपको याद रखना है नीचे का फ्लोर में जो पीस रहेगा that is drag and obviously ऊपर का रहेगा core. All right.
Yes, sir.
So you have a box like this, thank you, in which you are keeping a pattern. Okay, and these are the different types of pattern. Again, this is very important from examination point of view. Explain different type of patterns and explain any one in details by masquerade. Okay, so in this case, you have to just state this pattern, that is single piece pattern, split pattern, match pattern, weighted pattern, and you have to explain any one pattern with the diagram. So what is single piece pattern? Now you did not study all the patterns. You just study only those who are important from examination point of view, which are more likely to be asked. Okay. Like single piece pattern. Okay, so this is the most simple and inexpensive. Why the name single piece pattern? Because it is made out of a single piece. So this is what is your single piece pattern. It is made out of one piece. Now this pattern is kept in a molding box. ये जो आपका molding box बोलते हैं. And then this is the sand. So once you keep a pattern, then the sand is rammed around the pattern. Okay. Now, obviously, you will have to locate the pattern because when you are ramming the sand, that time the pattern will deflect. So, you have to provide some supports which will hold the pattern firmly. Now, these supports are not shown here. And if you are putting the supports, you have to also see that the support will get melted when you are doing casting. Now, this is a one piece pattern and this can be removed once the sand is rammed. Then you have to just pull this pattern. मतलब यहाँ पे आपको क्या करना है? You have to have some pulling arrangement, that is you can keep a screw. उसमें screw लगा के रख सकते हैं so that you can pull the pattern with the help of the screw. Then you have split pattern. The split patterns में the patterns is divided into two parts. And then these two parts are joined or aligned with the help of the dowel pins. Like this is an example or drawing of a split pattern. So this is a dumbbell. Now this split pattern, if it is split pattern, if it is in two parts, then there has to be a parting line. There will be a parting line. See, remember now this portion, इसका cavity will be cut in one half and जो this portion है, इसका cavity will be cut in another half. So the two half has to match properly. If they do not match properly, ये यहाँ पे shift होएगा, ये यहाँ पे shift होएगा. So you will not get a circle proper. ठीक. So that's why you have to have a dowel pins. तो ये जो मैचिंग है वो परफेक्ट हो जाएगा. You will get dumbbell properly. You will get a proper dumbbell if your matching is perfect. And then perfect matching is done with the help of this dowel pins. सो ये आपका है स्प्लिट पैटर्न. Then gated pattern. So this is an improvement over the simple pattern. And in which so far now I have told you only about the sprue. Okay, but feeding system. Feeding system means how the material is injected in the casting. So the like our feeding system. In case of human being, what is the feeding system? There is a mouth, then there is esophagus, okay, then there is livers, then there are small intestine, then there is bigger intestine. So this is what is our feeding system. So similarly in casting also you have a feeding system. So you have screw, then you have runner, main runner, then you have secondary runner, then you have gate, then you have branch gate. So this everything, this whole thing makes the feeding system. ठीक है. So feeding system, feed मतलब क्या, जो खाना खिलाता है. ओके. So similarly जो mold का क्या रहता है, खाना molten metal. Okay, so the molten metal has to reach to the cavity, so that is called as your feeding system. Like here now this is your gated pattern. तो अभी gated pattern में क्या हो रहा है, देखो आपका जो प्रोडक्ट है वो ये प्रोडक्ट है, दिस इज द प्रोडक्ट. ये जो राउंड जो है वो प्रोडक्ट है. ओके. नाउ दिस इज कॉल्ड द मल्टीपल कैविटी मोल्ड. व्हाई इट इज कॉल्ड द मल्टीपल कैविटी मोल्ड? बिकॉज there are more than one cavity, one, two, three, four. In this case there are eight cavities. In this case there are eight cavities which are cut in the mold. What is the use of multiple cavities as against a single cavity? In single cavity you will make only one piece, and if it is a multiple cavity, like in this example it is 8-piece cavity, then you will get 8 times production. Like suppose if you are making 300 engines in 8 hours, you can make 300 into 8, that is 2400. So this is the advantage of multiple cavity mode. So wherever possible, or if your products are very small, then it is always advisable, or it is always preferred to go for multiple cavity mold. And if it is a multiple cavity mold, then obviously you have no choice but to go for gated pattern. Gated pattern में क्या रहता है, ये जो है according to this you will get your product shape. Then you have a sprue here. Sprue मतलब सबसे बड़ा रहता है. हाँ, लाइक हम लोग जो चाय बनाते हैं गैस के ऊपर, जो जो हम लोग बर्तन रखते हैं, वो हो गया स्प्रू. बाद में स्प्रू में से हम लोग निकालते हैं एक ग्लास में या थर्मास में, बराबर है. सो दैट इज लाइक योर रनर. एंड देन रनर में से हम लोग कप में डालते हैं, डिस्पोजेबल कप या ग्लास कप, सो दैट एक्ट्स लाइक अ गेट. तो ऐसे है. तो दिस इज योर स्प्रू. ओके. देन स्प्रू मतलब इट्स अ बिगर फीडिंग सिस्टम. देन स्क्रू से मटेरियल आएगा रनर में. ओके. सो रनर इज लाइक दिस. ओके. एंड देन रनर में से यू विल हैव गेट. अभी यहाँ पे मिस्टेक क्या है, गेट उन्होंने काफी बड़ा दिखा है. नॉर्मली द गेट इज वेरी स्मॉल. व्हाई इट शुड बी वेरी स्मॉल? बिकॉज व्हेन द components has to be ejected out, that time we are interested only in this. We don't want this. गेट नहीं चाहिए, ये रनर नहीं चाहिए, स्क्रू नहीं चाहिए. दिस इज अ स्क्रैप. और ओनली जो स्पेरिकल शेप है, दैट इज व्हाट इज आवर प्रोडक्ट इज. स्पेरिकल शेप है वही अपना प्रोडक्ट है. ओके. So, अभी प्रोडक्ट के साथ आपका गेट भी है और रनर भी है. So we will have to cut it with the help of the grinder. So that's why gate has to be thin, so that you can cut it off across this very easily. As far as possible, we try that when we are ejecting the product, that time the products are de-gated. मतलब जब भी प्रोडक्ट को इजेक्ट कर रहे तभी गेट टूटना मांगता है. That is the best. because then you don't need a post processing operation of cutting the gate. So the best option is when the products are ejected, that time itself it gets degated. So when it is possible, only when the gates are thinner in cross section. यदि गेट का क्रॉस सेक्शन थिन रहता है, छोटा रहता है, तभी वो डीगेट इजीली होएगा. And then this gate, runner, screw, runner again you have primary runner and this is actually a secondary runner. ये secondary runner है और जो gate जो रहता है वो secondary runner और ये जो spherical piece है दो के बीच में दोनों के बीच में gate रहते हैं. So screw, primary runner or main runner, then secondary runner or branch runner and then gate. So this form the feeding system and once they are degated, then it goes for remelting. Again it is melted. It goes as a scrap, bangan, and it again goes to the foundry where it is remelted. Then you have match plate pattern. Okay, so this is what is your match plate pattern is, where the patterns has to be matched properly. So first three are very important from your examination point of view. Okay. These are very little complex and it will take much time, for you to draw in the examination and to explain. So you can no doubt you can study it, okay, but from examination point of view, you should ignore this, unless and until it is specifically asked, describe match plate pattern. But like these questions will be very rare, because we will give you freedom, to describe your own pattern. Because if the questions are asked like describe match plate pattern, then you need to study all the 10 patterns because you don't know which patterns will be asked. But if you have been given a choice that explain any one pattern, then you are happy. Okay. So again here the matching is very important. The lower portion is drag, the upper portion is cope. This is your cope side, this is your drag side, and this is how it has to be matched properly. So this is your match plate which is kept, and once you see that it is matched properly, then only your match plate is removed. Cope and drag patterns are exactly similar to the split pattern. Then you have follow board patterns. In follow board patterns, we use a board here, follow board, on which the pattern is kept and then the sand is rammed inside this. So since it follows the board, it is called as the follow board pattern. Generally, it is used for large pattern, and for thinner thickness. Like certain portions, they are structurally weak. Okay, so that has to be supported properly. Like here, uh, imagine this is a product. So now, if you keep something, this will get bent, isn't it? And there is a pressure, molten metal का pressure रहता है, isn't it? So under that pressure, this is going to collapse. So that's why, or under the pressure of sand, when you are ramming the sand, okay, then this may collapse. So that's why you have to keep it raised. स्वीप पैटर्न का मतलब है यू कैन प्रोड्यूस द सर्कुलर प्रोडक्ट्स, लाइक आपका जो पाइप्स रहते हैं ना, और लार्ज हॉलो पीसेस कैन बी मेड यूजिंग दिस स्वीप पैटर्न्स. सो स्वीप मतलब क्या करना है आपको, ऐसा घुमाना है. ओके. हाँ. सो ये आपका सैंड है, ये सैंड के अंदर ये बुश है जिसके ऊपर ये स्पिंडल है, एंड टू द स्पिंडल वी हैव अटैच्ड अ स्वीप. सो दिस रोटेट्स. सो रोटेट होने से क्या होता है, ये जो सैंड है वो निकल जाता है एंड देन यू विल गेट अ cavity, a clean cavity like this, in which you are pouring the molten metal. That is what is called as the sweep pattern. Skeleton pattern matlab this is used for very bigger casting like lathe machine ka base, milling machine ka base. So a skeleton is prepared first. huh? This is your skeleton. Hmm? And then this skeleton is used for preparing the mold. Loose piece patterns. They are made to have loose pieces in order to enable their withdrawal. हाँ, आपका प्रोडक्ट है वो विड्रॉ भी होना है अच्छी तरह से. Okay, so that's why we go for the loose piece pattern, so which can be withdrawn very easily. So this is an example of loose piece pattern. That is this. This is a loose piece anchor. This is a pin. Loose piece sand. देखिए. Okay, we'll continue tomorrow. Thank you so much. If you have any doubt, you please ask. Because it's 12:34, no? You might be hungry. Yeah.
Thank you, sir.
Yeah,
Thank you,
welcome.
sir.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank
Thank
you.
you, sir.